Conventional wall is not as efficient and effective as CLT, for example, like cast in situ. Then cross-laminated timber is easier to handle and assemble on site. It's strong, lightweight, sustainable. Then it is the floor of construction, as most of the work are being made and finished off-site. Then there's also impact to material and labor costs. CLT cost for material and labor may be lower as compared to traditional steel or concrete. So material cost saving may be as much as 15%. Also, labor demand for CLT projects are also less. So prefabricated panel require fewer work to place them.
So one of the main reasons we also chose cross-laminated timber was we could reduce the environmental impact when building the building, as we could build most of our parts outside and then ship it to our site, and do not disturb the nature of Coney Island too much. Also, we are aware of the benefits such as its sustainability and strength. Its fire performance, while questionable, we found is quite good because instead of burning to ashes, the wood will actually char and protect the structure. So instead, you could just replace the wood after a fire, if any. Also, we are aware of termites on site, so we will treat the wood for termites. So another type of sustainability and lean method, we use our PBUs. There will be a total of 45 modules for this, 9 on each floor, and we'll be using them at our toilets. We will fit each PBU with its necessary fittings, such as floors, walls, and any utilities, and ship it to site and install it on site. Again, to minimize the construction on site, to to ensure the ecosystem is not disturbed too much. So we conducted a sun path analysis, a heat analysis, and wind analysis to determine the facing of our building. From this, we concluded that our building should face the north-south facing, because it will be under the sun for the shortest amount of time day, providing it, making it less hot. And from the heat analysis, we can see the yellow is the hottest, followed by red and blue. To counteract this, we added solar panels on the roof to leverage the sun. And for the PBUs, we added green walls to cool the building down. Our wind analysis done was so that we could find the most efficient way to naturally ventilate the building. From this, we found out that if we add a void in the center, we'll actually be able to naturally push the hot air up and thus cooling the building more efficiently.
For the green building design, we decided to use LED for our lighting after doing a rough analysis comparing LED and CFL. So we calculated the watt saved per bulb, the total energy savings, and the money saved. Here is an example of one module with all the MEPs. So for the green walls, we installed green walls on the exterior wall of the washrooms, and it helps to reduce the temperature and also reduce the noise. For solar panels, since the top of the roof has the most amount of heat, we decided to put solar panels as a sun shield instead of putting gardens, as it requires more maintenance. So the total number of panels needed is 358, and the power generated in a year would be 481.8 kilowatts.
So throughout the project, right, we had some conflicts in between. So the first conflict was that in our group, we had two different designs, and we were actually contemplating whether to use the design 1 or design 2. So in the end, we picked design 2 because design 1 actually has a flat facade and it's quite rigid, and it doesn't really have like volumes or aesthetic towards it. And so the first one actually has the same length. Each of the modules have the same length. But then for design 2, we actually add depth and like aesthetic towards it because we made different sizes, like alternate inwards and outwards. So it actually like add some volume towards the building facade, and it also actually is quite harmonized with the surroundings. For the collaboration part, we use BIM 360 to share the model, and then this is our program schedule for the whole project. And using BIM 360 actually like speeds up our pace of the project, and we only meet up to like actually give updates and also ensure that everybody is on par with the schedule.
So this is some of our interior render images and exterior render images of our building. So that side is day view, night view. This is back view of our building, office, canteen, then meeting room. Then we use Lumion application for rendering of our building. So this is our final team effort video. So let's play the video and please take a look.
Just to summarize, at the start of the competition, the programs on the left were the ones we knew, and by the end of the competition, we picked up the programs on the right. Our team feels by far the most important program we picked up was BIM 360 because it allowed us to share the models online, and most of us could edit it all at once and allow us not to meet so often. We also thank SP BCA for organizing this competition because we understand each other's different disciplines better by the end of the competition, and we feel that we understand better how a building will progress from start to finish in the working world. Thank you.
thank you for the presentation. Just a general observation. So your beehive concept is a good concept, and actually there is quite a lot of scope for repetitions and modularization, especially since your beehives are quite similar in dimensions. But one thing, going into the construction method, I noticed that you all have a lot of steel members and components to actually do on-site bolting and what, so that actually reduces the construction productivity. Maybe going forward, if you look at it, to take it a step further, might as well harness these repetitions and what to do integrated components, make it as one whole module so that you have less things to do on site. So just an observation on that part, to make better use of DFMA technology to improve construction productivity.
Thank you, ma'am. But we actually made it quite made it repeat itself because we felt that in the long run, if you wanted to add or take away modules, it could be done easier than a normal building. So that's why it's so repetitive, and that's why each module is by itself.
Because you have a lot of structural channels and steel members, so that will take quite a lot of time to put the pieces together. So maybe if you integrate one whole component together, that the installation time on site will be faster and improve your overall construction productivity. Just a point to take note that you all can look at.
Thank you, ma'am.
Following up on that point, can I understand from other than the strength and or the ease of construction, why steel? Why is steel your structural component? Is there any other reason? If that's it, then that's fine. You know, so
No reason.
any other reason why steel is your main core structural for a 5-story building?
No reason, yeah.
No reason.
Just
Except for it being it's got strength and it's easy to install.
yeah.
There are other materials that you could have chosen. Because inside your material list, you already have CLP, which can be used as a structural component. So you might want to study that. Then maybe instead of posing the question to you, I'll pose degradement. CLP is cheaper than concrete. So CLP, because from my experience, it is material cost-wise.
Okay, if you look at, because the property of CLP being stronger in terms of weight to volume ratio, so that could cut down. But
Using steel.
yeah, that's the question I related to these two. I really can't see how you can fit the steel structure, PPVC, and the CLT together to produce.
Plus PBU.
Now, okay, PBU aside,
Aside,
it's a hybrid building. Because
Hybrid, no.
yes, hybrid, but you have a steel structure on the outside. Where is the PPVC is going to fit in? And how you are going to credit with CLT again? Is that your intent?
Yes.
Then the benefit of the PPVC might not be there.
Can we go back to no, it's a discussion. I mean, we are trying to share some of our experience. It's not so much like, wait. That's not our intention. Okay, we are just trying to understand where you're coming from. And if we could, we want to share some of our experience that we have with some of these materials. Because what you are struggling with, we struggled a few years ago as well. So that's the main reason.
If I may be allowed to so-called help them.
Sure.
Okay, one of the things that I always like to tell people whom I work with in the office is if you're going to scratch your right ear, you scratch it this way, you don't scratch it. Right? And one of the things that I appreciate about this design, this proposal, is that it is basically scratching the right ear this way. It's actually a very, very simple, clear idea that is actually very, very flexible. So even though, for example, maybe yes, your proposal is steel and you can be that can be looked at from a so-called positively or negatively or whatever. The scheme is designed in a way that if you chose to do it in PPVC, it's doable because everything is very, very well, very modulated. If you chose to do it in MPT, it is also possible. So I think in this regard, these are the benefits that maybe consciously or unconsciously, by design or by accident, is an outcome of this proposal. It's flexible enough to accommodate all of that. you know, it's fit for a client that today he wants to do it in MET, tomorrow he changes his mind, he wants to do it in PVC, and next week he wants to do it in steel, and the week after he wants to do it in regular conventional construction. It can all work. I think that's one of the strength of the scheme, and it has a certain character to it. Whether you want to do it flat, if you want to save costs, whether you want to do it every floor or every other floor, you can basically create all sorts of variations to this honeycomb concept that I think is still clear as an idea. This idea of this narrative of you have beams on the side, you have workers. It works, yes, it works and it makes sense. You know, in the words of Steve Jobs, simplicity is the highest form of sophistication. So there's definitely an element of that. One of the things that I will say though, of course, we talked about using MET, CLT. To do so means that you have to, you mentioned termites and charring. So of course, if you use MET, you actually have to supersize columns in order to accommodate for charring. If it burns, you can't just replace it. You know, the reason why, if you do MET, the columns and the beams have to be supersized so that in case of a fire, the charring is basically a protective layer. But it's not as simple as just anyhow replace kind of thing. Termites, you need to poison soil. And for a site as beautiful and as naturally sensitive as a Coney Island, that is something to think about. But these are things that I suppose we can, in a way, like I said, we take liberties about it because it's a student competition. It's about ideas. It's about how ideas, by, like I said, by design or by accident, can take us to certain things. Maybe the other comment that maybe that I would like to make or ask is maybe more of a comment is that the design, I think, is clear. It actually works as a office space because you can ask an operator to come in, design, lay out however which way they want. But it becomes a question of if this building were built in the campus of SP, if it was built